Good morning, students. Yesterday, as you know, we completed what is called enthalpy and work done in a chemical reaction. Today, we want to start new point from thermodynamics. Thermodynamics. That is enthalpies of physical transformations. Enthalpies of physical transformations. Physical transformations. You know that enthalpies of physical transformations, in this there are three types of enthalpies. First one is enthalpy of phase transition. Enthalpies of phase transition. Second one is enthalpies of atomic and molecular changes. And third one is enthalpies of enthalpy of solution. So we are going to study in detail what is enthalpies of phase transition, what are called enthalpies of atomic and molecular changes, what is called enthalpy of solution with examples. But before that we want to know the definition, and then we want to know the example of each enthalpies of physical transformations. First of all, enthalpies of phase transition. Enthalpies of phase transition. Enthalpies of phase transition. Enthalpies of phase transition. First of all, here in this enthalpy of fusion. You know that fusion means melt. Solid is converted into liquid. That is called as fusion. For example, you know that enthalpy of fusion is denoted as delta H fusion. You know that phase transition means substance is converted from one state to another state, but chemical composition remains same. For example, you know that H2O solid, it is converted into H2O liquid, it is converted into H2O gas. Means there are three different states: solid state, liquid state and gaseous state. But chemical composition is same. You know that ice, after gaining heat, is melted, and for that melting the word used is fusion. H2O solid is converted into H2O liquid, and liquid water after heating converted into water vapors, that is H2O gas. You know that when we cool water vapor, then it is converted into liquid water, and when liquid water is cooled, then it is converted in ice. This is called as phase transition. One substance is converted into another phase. Solid phase is converted into liquid phase, and liquid phase is converted into gaseous phase. So first of all, we want to know what is called enthalpy of fusion. It is denoted as delta H fusion. So here From this example we can know the definition. You know H2O solid, it is converted into H2O liquid. Delta H fusion is equal to plus 6.01 kilojoule plus 6.01 kilojoule per mole at 0 degree Celsius per mole at 0 degree Celsius. So 1 mole of solid after gaining 6.01 kilojoule of heat, in thermodynamics it is called enthalpy. So 1 mole of solid ice is converted into 1 mole of liquid, that is water. So change in enthalpy taking place for melting 1 mole of solid ice is called enthalpy of fusion. Or we can write the definition of enthalpy of fusion as like this. Enthalpy change that occur when 1 mole of solid is converted into liquid. When 1 mole of solid is converted into liquid, that is called enthalpy of fusion. Enthalpy change that occurs when 1 mole of solid is converted into liquid is called enthalpy of fusion. Now here when 1 mole of solid ice is melts, another example, reverse of this process is called, that is enthalpy of freezing. That is H2O liquid, it gives H2O solid. So freezing, that is delta H is equal to minus 6.01 kilojoule per mole at 0 degree Celsius. So reverse of this is called as enthalpy of freezing. So again we can define enthalpy change that occur when 1 mole of liquid is converted into solid, that is called as enthalpy of freezing, and it is denoted as delta H freezing is equal to, you know that when 1 mole of solid ice is converted into liquid, 6.01 kilojoule of heat is absorbed, and when 1 mole of liquid water is converted into solid, then 6.01 kilojoule of heat is released. So this is about enthalpy of fusion and enthalpy of freezing. Now another definition, that is enthalpy of vaporization. Another definition, enthalpy of vaporization. Denoted as delta H vaporization. So you know that H2O liquid is converted into H2O gas. Means vaporization takes place, liquid is converted into gaseous state, and when this process takes place, and during this whatever heat, that means enthalpy is changed, that is called as enthalpy of vaporization. So here enthalpy of vaporization is plus 40 kilojoule per mole. Delta H vaporization is equal to plus 40 kilojoule per mole plus 40 kilojoule per mole. What this indicate? 1 mole of liquid water absorb 40 kilojoule of heat and it is converted into H2O gas. That's why during this process whatever enthalpy or heat change takes place, that is nothing but enthalpy of vaporization. So another example, that is, this is at 100 degrees Celsius, at 100 degrees Celsius. But if temperature is 25 degrees Celsius, then value of delta H vaporization is different. That is H2O liquid, it is converted into H2O gas. So delta H vaporization is equal to plus 45.07 plus 45.07 kilojoule per mole, but this is at 25 degrees Celsius. So here what will be the definition of enthalpy of vaporization? The definition of enthalpy of vaporization is, it is the enthalpy change when 1 mole of liquid without changing, it is the enthalpy change taking place or accompanying the vaporization of 1 mole of liquid without changing its pressure at constant temperature. At constant temperature is called enthalpy of vaporization. So these two are the examples of vaporization. Vaporization means liquid is converted into gas. Now we want to know what is called condensation of vapor or enthalpy of condensation. Enthalpy of condensation. So reverse of this is called condensation. Enthalpy of condensation. Condensation denoted as delta H condensation. So here you know that H2O gas is means vapor is converted into liquid. H2O gas is converted into H2O liquid. So enthalpy change during this condensation process, that is enthalpy of condensation, is equal to here minus 40 kilojoule per mole at 100 degrees Celsius. At 100 degrees Celsius. So here you know that liquid is converted into gas by absorbing 40 kilojoule of heat at 100 degrees Celsius. Here gas is converted into liquid by releasing 40 kilojoule of heat or enthalpy at 100 degrees Celsius. So reverse of vaporization is called condensation. Now the next point, enthalpy of sublimation. Next definition, that is enthalpy of sublimation. Enthalpy of sublimation. Enthalpy of sublimation. Sublimation. So enthalpy of sublimation is denoted as delta H sublimation. You know that solid is converted into liquid, that is called fusion. The reverse of fusion is called freezing. And you know that liquid is converted into gas, that is called vaporization. And gas is converted into liquid, that is called condensation. Now the third definition, enthalpy of sublimation. What is called sublimation? Solid is directly converted into liquid, that is called as sublimation. So H2O solid is directly converted into H2O gas. When solid is converted into gas, that is called sublimation. And here H2O solid is converted into H2O gas without converting into liquid. That process is called as sublimation. So So here enthalpy of sublimation for this process is, that is 51.08 kilojoule per mole at 0 degree Celsius. So here it is important to know that we can find out the relation between enthalpy of fusion, enthalpy of sublimation and enthalpy of vaporization. That is, enthalpy of sublimation is equal to enthalpy of sublimation is equal to enthalpy of sublimation is equal to enthalpy of fusion plus enthalpy of vaporization. You know that what is called fusion? Solid is converted into liquid, that is called fusion. You know that liquid is converted into vapor, that is called vaporization. And sublimation means solid is directly converted into gas. So what is the relation between these three? Enthalpy of sublimation is equal to enthalpy of fusion plus enthalpy of vaporization. Again we can write these examples of enthalpy of fusion and enthalpy of vaporization. You know that enthalpy of fusion of water, that is H2O solid, it is converted into H2O liquid. Here enthalpy of fusion is equal to plus 6.01 kilojoule per mole. And you know that enthalpy of vaporization, that is H2O liquid, is converted into H2O gas. Here enthalpy of vaporization is equal to, that is plus 45.07 kilojoule per mole. Here sum of these two reactions, that is it gives H2O liquid get cancelled. What remaining? H2O solid, it gives H2O gas, and delta H vaporization is equal to, that is 51 plus 51.08 kilojoule per mole. So enthalpy of sublimation, here it is enthalpy of sublimation, enthalpy of sublimation is equal to enthalpy of fusion plus enthalpy of vaporization. So here the relation between enthalpy of sublimation, enthalpy of fusion and enthalpy of vaporization we can understood from this example. So enthalpy of sublimation is the sum of enthalpy of fusion and enthalpy of vaporization. Now the next point, enthalpy for the atomic and molecular changes. Enthalpy for the atomic and molecular changes. Enthalpy for atomic and molecular changes. You know that in this, the first definition, enthalpy of ionization denoted as enthalpy of ionization, delta H ionization. You know that here, for example, sodium, that is in gaseous state, gives Na plus gaseous plus electron. So enthalpy of ionization is equal to, that is 494 kilojoule per mole. 494 kilojoule per mole. What this equation indicates? Gaseous atom of sodium is converted into gaseous ion of sodium, means electron is removed from sodium. How much heat is required? 494 kilojoule of heat is required to remove one electron from that sodium to form gaseous sodium ion. This is called as enthalpy of ionization. This is called as enthalpy of ionization. So, to remove one electron from gaseous atom of sodium to form gaseous ion of sodium, 494 kilojoule of heat is required. That's why it is called as enthalpy of ionization. Atom is converted into ion, that is called as ionization. Now, reverse of this is called as electron gain enthalpy. Electron gain enthalpy. So, you know that electron gain enthalpy, electron gain enthalpy, written as delta H Eg means electron gain. You know that chlorine, that is the gaseous ion of atom of chlorine, it accepts electron to form Cl minus gaseous. So, electron gain enthalpy for this reaction is minus 349 kilojoule, minus 394 kilojoule per mole. What this value indicates? This value indicates that when one electron is added to gaseous atom of chlorine to form Cl minus ion, 394 kilojoule of heat is released. 394 kilojoule of heat is released. You know that amount of heat required to remove the electron, that is called as enthalpy of ionization. But when electron is added to neutral gaseous atom of chlorine, it releases 394 kilojoule of heat. That is called as electron gain enthalpy. Now, next definition is, that is enthalpy of atomization. Enthalpy of atomization. Next point, enthalpy of atomization. Enthalpy of atomization. You know that denoted as delta H atomization, that is enthalpy of atomization. You know that chlorine, that is the molecule of gas, chlorine gas molecule Cl2, it is diatomic. You know that we want to separate these two atoms, that is chlorine gaseous plus chlorine gaseous, and enthalpy of atomization for this reaction is, that is 242 kilojoule per mole. 242 kilojoule per mole. So you know that this chlorine bonded with covalent bond. One molecule of chlorine consists of two atoms of chlorine. To separate these two atoms of chlorine, we want to break this bond. To break this bond, how much heat is required? 242 kilojoule heat is required. And enthalpy change taking place during this process is called as enthalpy of atomization. Another example. For example, CH4 gaseous. You know that methane. Molecular formula is CH4. Physical state G means it is gaseous. You know that here we want to separate this carbon gaseous plus 4 atoms of hydrogen that are gaseous. So, enthalpy of atomization for this reaction is 1660 kilojoule. 1660 kilojoule per mole. What this indicates? You know that molecule is converted into atoms, that is called enthalpy of atomization. In methane there is 4 carbon hydrogen bonds. So to break all these 4 carbon hydrogen bonds from 1 mole of gaseous methane, how much heat is required? 1660 kilojoule of heat is required. That is called as enthalpy of atomization. Okay,